The next one is the most important in examinations also they ask spin orbital coupling parameters. We already know what in the previous class I told you spin orbital coupling is nothing but LS coupling and ZZ coupling. LS coupling is obtained from the Russell Sanders coupling is nothing but capital N and capital S. This capital L values is obtained from the small l values addition, and S is small SL values addition. But JJ coupling is obtained from small l and small s couple, we give JJ coupling value. So these two spin orbital coupling is takes place in the particular parameters, and we get that spin orbital coupling parameters. In order to know that effect of spin orbital coupling, the parameters used as zeta. So this term they have in this topic we have different term letters and again the symbols. So we give that particular value name of the particular, this one is zeta, z model lo untundi. So we easy remember zeta and delta. Zeta is a single electron spin orbital coupling constant. Oka electron, only one electron is coupled in the particular constant is nothing but called as zeta. Where lambda is nothing but we already know lambda means wavelength. So how many waves are obtained? So the number of many of electrons. So many electrons are spin orbital coupling constant we called as lambda. So zeta is a property of the configuration, whereas the lambda is a property of a term. కాన్ఫిగరేషన్ అంటే ఏంటి, ఒక ఎలక్ట్రాన్లో ఎన్ని ఎలక్ట్రాన్స్ ఫిల్ అవుతాయి అన్నది. టర్మ్ అంటే ఏంటి, నెంబర్ ఆఫ్ పాసిబిలిటీస్ ఆఫ్ పర్టికులర్ ఎలక్ట్రాన్స్ వి కాల్డ్ యాజ్ term. So the magnitude of these parameters can be obtained from the emission of spectra of free metal ion. So electron ఎలా అవుతుంది, so it move from low level to high level. So the magnitude of this particular means emission. So electron is moved from out of the particular sphere. So here the parameters can obtained from the emission spectra of a free metal ion. The spin orbital coupling constant zeta is for due to the electron is always positive. So only one electron antunnam kada, so it is always in positive direction, is given as zeta nl is e square h square by 2m square c square q naught z power 4 n cube l plus of, it is only one electron, we get positive number of l plus 1. So n comma l are the quantum numbers. We already know n is the principal quantum number, l is the additional quantum number. It is clear for the equation for the zeta, it depend upon only n and l values. Zeta for the 3D electrons, 3D transition series, it is the value of the particular is the wavelength is 154 to 829 centimeter inverse, whereas 4D electrons 500 to 1000 centimeter inverse. For any D2 configuration, lambda and zeta are related to the lambda is almost equal to plus or minus zeta by 2s plus or minus zeta by n, where n is the number of unpaired electrons, whereas S is the spin of the electron. Whereas if the n value is equal to 5 or less than 5, the lambda is positive. If n is greater than 5, the lambda is negative. Each term is split by spin orbital coupling into the states specified by z values. So it is the most difficult topic to understand, but it is the must and should question. So only the theme is we indicate the zeta is indicated for the single electron, where lambda indicated the number of electrons which are involved in spin orbital coupling and ZZ coupling. So they give the different parameters of the particular L and S coupling and ZZ coupling. So you should practice, then only we get this answer in examination. Each term is split by spin orbital coupling into states specified by z value. So what is meant by z value here? L and S couple. So the question is spin orbital coupling parameter. So here the energy term defined as between j and j plus 1. The levels, first level is j level and second one is j plus 1 level, is given as delta E j comma j plus 1 is equal to lambda into j plus 1. The term for the D2 configuration states increasing Z value. Already you know the D2 is a less than off field, so the Z value is the least J value is the ground state. It is nothing but triplet F2 is the ground state, next is triplet F3 and triplet F4. So it, for example, it is J and it is J plus 1, it is J plus 2, so on like that. So here J comma J plus 1 terms, the terms of our D2 configuration states with increasing the Z value, the lambda is positive, and the terms D8 configuration is gives state with decreasing J values. Already told it is more than half field, the J value is the least highest J value is the ground state. Next one here J plus 1 అనుకున్నారు అనుకోండి, ఇక్కడ J ఇక్కడ J minus 1, so it is a decreasing in the J value. Okay, so here the lambda is here negative, so here negative means nothing but 4 minus 3, it is nothing but minus 1, 3 minus 2, it is nothing minus 1, so that is the indication of minus 1. So D2 is J 2 comma 3 comma 4, where delta is plus zeta by n, where D8 Z value is 4 3 2, it is a decreasing value, it is lambda is minus zeta n by n. So the D2 configuration delta E2 by E, it is again in the previous class I told you this energy difference is explained by the ABC or ABC values, here only explained by the lambda. So this is the spin orbital coupling parameters are only 2 parameters. So here the lambda value is give that zeta values, these zeta values are explained where here lambda is like this, whereas 3 lambda is 3 into for the D2 configuration. So whereas delta E 3 comma 4, delta E 4 3, and J values are triplet 3 2. So these J values 2 comma 3, 2 and 3, this energy difference is 3 lambda, whereas 3 and 4 comma 3, 4 comma 3, it is 4 lambda, whereas 3 comma 4, whereas D8 configuration like this. So here D8 and D8, so we can observe that the energy levels EJ for the J values can be calculated by EJ is of J lambda into J plus 1 minus L into L plus 1 and minus S into S plus 1. So this is the coupling constants of spin and orbital. It is addition of the particular J values. Okay, so this is the diagram for the common diagram for the D2 configuration and D8 configuration. In the D2, least J value is the ground state, so you write like this. Again the term letters, and L is 3 and S is equal to 1, 3 plus 1 4, 3 plus 1 minus 1 3, 3 minus 1 2, whereas highest J value is the ground state, 3 plus 1, it is nothing but 4 is the least J value for the D8 configuration, next 3 2, whereas singlet D, where L is equal to 2, S is equal to 0. So this is the term, let us again L is equal to 1, S is equal to 1. So these values are obtained from that. Last class I told that the arrangement of electrons in the different shells, you get all these terms for the D2 configuration. Okay, good night.